You mentioned earlier on that you'd flown all three V-bombers and just referred to them. I wonder if you could detail your experiences a little bit more on each one of them.
In the early or the late 50s or early 60s, whenever they were flying, the chief designers of Handley Page, Vickers and Avro's were interested in my opinion, on behalf of the ARB, of the flying qualities of these three bombers, because in principle one could, if you remember all of them, the Victor, the Valiant and the Vulcan, you could tear the wings off, put a people carrying fuselage and stick the wings back on and say there's a civil transport aeroplane, keeping the same wing fundamentally, and particularly the power control systems, which is what they were primarily interested in. Because, see, the bombers before that were manually controlled. Even the Sperrin, which was an experimental servo-tabbed aeroplane.
And the Canberra.
And yes, and the Canberra, that's right. But these were big aeroplanes. I mean, big for their day. We wouldn't think them big now, but they were quite big and heavy. And they had to have power controls because they went to quite high speeds and high Mach numbers. Particularly what was called the Black Valiant, which was a very high speed, low level bomber, stressed for about, 580 knots, something remarkable at low level. So anyway, I did one long flight on each of them. I went up to Woodford and I flew the Vulcan prototype with Rolly Falk. Now, you can't stall a Delta in those days. It was a military aeroplane. But apart from that, I looked at the flying control systems. I took it to a fairly high Mach number, fairly high speed. And it was great. It worked well. I mean, the cockpit was lousy. You were jammed in tight alongside the other guy. The view wasn't very good. I mean, the starboard window, for example, only had it was made of metal with a little round window in it. So the view wasn't much cop. And you had to be very careful with the aeroplane on approach and landing because it was longitudinally unstable at low speed, high incidence. And as you came into land, the stick forces were all in the wrong sense, and you had to fly the aeroplane very carefully and not let it get slow and not let it start to sink. Otherwise you could have a job to salvage it. I did 2-3 hours. It had a very high performance. We shot up, to 40,000 feet in no time flat. I enjoyed it. Of course, I was only a kid then. I was prepared to fly anything under the sun. And it was a great flight. And I didn't overdo the report though. I wrote a good report on it and said where fundamentally they would have to think hard if they turned it into a civil aeroplane. And it's always the same. It's always high incidence and stalling on these things. Now, the Valiant was a different kettle of fish. It was an earlier design than the others, and it was pretty agricultural. The view was lousy. The seating position was awful. It was terribly complicated. It had a mass of manual reversion and backup controls, and it also had, and this was the biggest pain on the Valiant, it had a little stick above the main control column, and it had two lights on the dashboard. Now, if the main elevator hydraulic circuit failed on the Valiant, you could fly it in manual with a servo tab on the elevator, working the elevator for you to cut down the loads. But this tab was always there. Of course it was always there. But you had to keep it more or less in trim, because if you let this tab get significantly out of trim when you were flying in power, if the power failed suddenly, the tab would take over, put on a large angle of elevator, and it would take the wing straight off the airplane. So the whole time you flew the Valiant, you had to watch these two little lights on the dashboard. And if two little amber lights, I think they were, if the top one came on, you had to press this little stick forward until it went out. If the bottom one came on, you had to press this little stick backwards until it went out. And this kept this servo tab on the main elevator more or less in trim, so that if you then suddenly lost power on the main elevator, which you wouldn't know, of course, if it were a sudden failure, you wouldn't wreck the aeroplane. You'd get quite a bit of G. You know, it would pitch up or pitch down, but it wouldn't be destructive. Now, we did what we could on that aeroplane. I think you could get quite close to the stall on that, and it flew reasonably well. But of course, there wouldn't be any question of having that tab needing constant attention by a civil airline pilot. In fact, I am amazed that the RAF ever bought it. The Valiant in the event didn't do much. It ran out of life, and towards the end there was a notice one day which said that all Valiants are grounded as of now, and they were all grounded because they were right out of airframe life, and they'd hardly done any flying. I don't know what the hell they made them of. They must have made them of some very fatigue prone material in the main wing sections and, you know, the main structural parts of the airplane.
Wasn't there a change of tactics to low level at one? You know,
yes, there was.
Missiles came in, they had to operate low down.
That's why they did. It was called the Black Valiant because it was painted black, and it was specially strengthened for the best part of 600 knots. A VD on that, the design diving speed, would have been about 600 knots. I didn't fly that one. Jock Price did a lot of work on that. But of course it must have given you a terrible ride in turbulence, low down. That's always the snag, you see, with high speed, low down work. Now what's the last one?
The Victor.
Oh, the Victor. I flew that with Hazel at Handley Page, and it was quite amusing really, because when we walked out to the aeroplane, Hazel said, "Now there's one thing you've got to learn on this aeroplane." I said, "What's that?" He said, "It's the drill for abandoning the aeroplane if the ejection seat fails to fire." He said, "It's long and complicated, and you've got to learn it like mad, because," he said, "if you don't learn it, you won't get out of the seat. And if you don't get out of the seat when you are supposed to," he said, "you'll die." So I said, "Okay then." So he spent about half an hour, and I was rehearsing this drill. You had to undo your harness, undo the oxygen, get rid of all these tapes and stuff. But you mustn't undo the parachute harness, see? And you know, it's amazing. If you weren't careful, you could find yourself undoing all these things and undoing the parachute, because every time you landed, not having had to jump out, this is what you did. You undid all these bits and pieces, you undid the harness, and got out of the aeroplane and walked down the ramp, didn't you?
And left the parachute in the seat.
Yes. Whereas on this occasion, you had to undo all this other rubbish, but for God's sake, keep the parachute harness on, and then go off and jump out of the hole. And Hazel said, "Now, when you've got that," he said, "wait off." He said, "Flying the aeroplane is a piece of cake." So I did 2 flights on that aeroplane. One with Hazel, which was okay, and again, it flew perfectly well. The controls were lovely, but you couldn't take it to high incidence. I mean, one of their guys, a bloke called Spud Murphy, took it to high incidence later and got into terrible trouble. So did Peter Baker. He went in a Victor in high incidence at about 56,000 feet. It took him half the sky to get out of it. So it was a disaster at high incidence. The other thing I didn't like, if you remember the shape of the Victor, the fuselage came along, and then it swept down over the windows to a long pointed nose, and these windows actually were that shape, and they were a long way away from the pilot. When you sat in a Victor, it was like driving a motor car from the back seat. It was uncomfortable. You kept peering like this, wanting to get closer to the window, but of course you couldn't. The window was miles up there. But it flew very well. The power controls were great. The other thing that the old man, that's Handley Page, discovered through talking to Hazel, is that if you came in for a landing at mid-CG, it would actually land itself. You didn't have to fiddle with the stick at all. You just left it alone. And when you got close to the ground, you closed the throttles. It pitched itself up a titchy bit, and it sat down as smooth as a nut. So we did several of those.
But actually landed in its ground effect.
Yes, it did, yes.
In its little cushion.
And BBC television came along that night, and they took a shot of the machine landing, and then they took a shot of me talking about it. See, because they didn't want Hazel talking about it, because it was his aeroplane. They wanted an independent person. And there was the old man saying to me, "Now, is it true that the aeroplane will land itself?" And I said, "Yes, of course, it will. I've done it 3 or 4 times. And then I said, "But of course, only at mid-CG." He didn't like that. But it was true.
Of course, they had a lot of breakages with tail failures, didn't they? On two of them.
They had that frightful breakup over Cranfield. They were doing a flutter program. Do you remember? Mm. And one Victor went over Cranfield at about 100 feet, and in a split second it was a cloud of aluminium dust. It just broke straight up. It fluttered. And you know, later they discovered that the flutter speed calcs were all to hell, and the critical flutter speed was about 100 knots less than they'd calculated. And I
never knew flutter could produce such violent forces.
See, there's one interesting thing about airframe structures as compared to a human body. A human body, for a short period, can tolerate strains that it can't tolerate for a long period. For example, if you do a split-ass turn in a fighter, you can pull 8 or 9 G for a second and a half, 2 seconds, so long as you then back off and come back to about 2 or 3 G. But you couldn't hold 9 G for 7 or 8 or 10 or 15 seconds. But you can tolerate very high peak loads for a very short period of time. Now, the difference between the human body, which is accommodating and elastic, with an airframe structure, is that the moment you exceed ultimate on a structure, it will fail. I mean, it's ultimate, it's actual ultimate. If you take a piece of structure past its breaking load, it doesn't bugger about, it just breaks. It goes pow, and that's the end of it.
Because did the same thing happen over the RSC, because they spent a lot of money dredging the remains of that one up?
I don't know what happened there. That went in a long straight dive and hit the water at some fantastic speed. No, I'm not sure what happened with it. They lost quite a number of Victors.
Yeah.
But of course, it's is it still serving as a tanker?
Only as a tanker.
Yeah.
There was one over at Lynham the other day.
Yeah.
Which do you think was the easiest to fly, from the PO prune point of view?
Boy, that's a very hard question.
I mean, your 16-year-old schoolboy doesn't come in here, does he?
No, he doesn't. You see, they were all actually... you see, when I talk about flying, I mean the response to the controls and how the machine is for general stability and controllability, which is a very sort of purist interest. If you put that aside and say, well, what are they like anyway? Christ, they were awful. I mean, they were a pain in the arse to get into. You had to climb up long ladders or go through some horrible little hole somewhere and jam yourself into the cockpit of a Vulcan. The Valiant had a dreadful flight deck full of pipes and steam and stuff. You know, I've said before, our cockpits years ago used to look like the stokehouses of trawlers. They were awful. The view was lousy. And, of course, with the Valiant, you had to keep fiddling with this little thing. And the Victor was just a pain because you couldn't properly see out of it. You were too far away from the windscreen. So...
And they're all difficult to get out of in an emergency.
Yes,
but only the pilot said they had the ejector seats.
Well, if I had to pick one, in spite of its instability on the approach, I would pick the Vulcan, because you sat up on top. You had a conventional cockpit, and in effect you almost had a bubble hood, you see, like a Hurricane or a Split, and it was comfy. Once you were in, it was okay. You were warm and comfy, you could see where the hell you were going, and it was a nice aeroplane to fly.
Can we move now to Concorde?
When I come to Concorde, I would like to feel that I could talk for 3 or 4 hours about the most interesting things. And the truth is that it is so good and so easy and has or had so few snags that is hardly anything to say about it. You see, when you are a certification pilot like I was, it wasn't my job to go and fly aeroplanes and tell people how good they were. Everybody knew how good they were. They were only interested in how bad they were and where the snags were and what they had to put right. I spent my life as a professional critic, which is not a very pleasant life really, because people don't like critics, do they? You are not loved by your fellow men if you are a professional critic. But that was my job. When I came to fly Concorde, the biggest, it's a bit like the Victor, the biggest snag with flying the early Concordes was getting dressed and getting into it. A bit like a spaceman, because we wore these pressure suits. We wore full pressure helmets. We had an air ventilated under system. It took an hour to get dressed. A whole hour. Because these suits were made to measure, to very fine limits. and you had to get dressed in the crew room. Then you were taken out to the aeroplane in a truck, a bit like these Apollo spacemen who go out and fly these spaceships. And we had full pressure helmets, you see. By the time we were kitted out for Concorde, we could have walked on the moon in that gear without any trouble. Then it takes ages to get into the aeroplane, because although the pilot's seat comes right aft, and you get in it back here, and then the chap straps you in and makes all these connections, and there's umpteen connections. Then you motor yourself forward, you put your straps on, pull tight, and then you can't even turn your head. In the prototype aeroplanes, you couldn't turn your head. With this huge helmet on, all you could do, I had a hell of a job to look sideways and catch Trubb's eye. But of course it had perfect intercom, so you really didn't need, and all the things you had to reach, you could reach. The engineer could reach the things you couldn't reach, so the machine was quite safe to fly. The prototype, of course, had a metal visor, so that after you took off and pulled the nose up, and then pulled the visor up, it was all steel. It came up and it blocked out all the forward view. Now, a lot of people would say, oh, isn't that terrible? You still have the side windows. But it wasn't terrible, because you think, even now, you can buy a ticket on a 7-4 to go to New York on a dirty winter's night. The weather can be, the base can be 200 feet in the UK, it can be 200 feet in New York. The captain takes off, he's into cloud, pitch black night. The next time he sees out is the approach lighting at New York at 200 feet. So, psychologically, there should not be a problem in flying an aeroplane without forward vision, because you do it most nights and you always do it in cloud. But what pilots didn't like was not having forward vision when they could have had forward vision. That's what upset them. We were prepared to certificate the aeroplane without forward vision in controlled airspace on the understanding that the machine would always be under radar guidance, which indeed it would, and is. But it was the Americans. See, every now and again the Americans do something quite tough, and they said no fear. And because of the Pan-American interest in the aeroplane, they won the day. And I'm very glad they did win the day. They said, we are not having that aeroplane without forward vision. So all these glass manufacturers, like Triplex and whoever, they had to go back to the drawing board and produce glass which would take sustained Mark II crews. And they did it. And if you look at the visor of a Concorde now, it's got, I don't know, either 2 or 4 long, thin windows. And now when you fly it, you pull the nose up, and then you pull the visor up, and you can still see forward. You can still see an awful lot of nuts and bolts and rivets, mind, but there are these windows through which you can have a forward view. And it is quite comforting.
You had to dress up in these suits, presumably, because you're operating at around 60,000.
Yes.
And if you got decompression at that height, you just boil.
Oh yes, you would. You would be dead within 15 or 20 seconds. And not only that, experimentally, the Concorde had to go to about 65 or 66 to prove 60,000. See, the operating envelope for a Concorde, it starts at 50 and it finishes at 60. But there are various systems which look after the aeroplane up to about 65 or 66. And the prototypes had to go up there. Now, if you had a decompression failure at 66, the cabin equivalent altitude would have been 80 because of the suck effect. Not only would the static pressure be 66,000, but the machine would be hurtling along and there would be a Venturi suck effect on it. And they reckon that inside the cabin you'd have an equivalent altitude of 80. Now, the 2 oldest guys who flew Concorde experimentally were Turcar and myself. And I think I'm a bit older than Turcar. And apparently, the medical people thought very long about Turcar and me flying the aeroplane, except that he was the big knob over there and they couldn't really stop him. And when it came to me, I didn't learn this until later. They were a bit nervous. But anyway, I did the whole of the safety survival course, which it included very elementary things, which I'm very glad I did, like how to get into a one-man dinghy if you've bailed out and finished in the sea. Do you know, if you don't know how to get into a one-man dinghy, it's almost impossible. But if you do know, it's a piece of cake. And we used to practice this in the pool at Farnborough.
What dinghies did you have during the war, the Avenger?
one-man dinghies. But no one ever said, do you know how to get into them? But these days, you were shown everything. So, and then we did all this pressure breathing. See, I'm really supposed to be talking about Concorde, but...
Well, it's all part of it.
Yes, but this pressure breathing, gosh, you've got to be careful. Because you sit in the pressure chamber at Farnborough, and you're in a little one, all by yourself. It's no bigger than like a coffin, and it's got glass windows, and there's doctors outside looking very nervous, and you're inside. You're already at 25,000 feet, with the visor up, and you are breathing oxygen. They pull the plug, they do something, and this blasted chamber, it goes straight to 80,000 feet. And the visor comes down with the biggest bang you have ever heard. It's automatic, see, the visor comes down, and the pressure breathing comes in. Now, I watched Concorde do it. I nearly died of fright, because the only bit of him unprotected was his neck, this bit. And it came out here. It came out like Dracula. It was out there. And I said, look at that. And they said, that's okay. That happens all the time. And then, when pressure breathing comes in, you get this overwhelming urge to take a deep breath. And that's what you mustn't do. If you take a deep breath, now I've forgotten the pressure, but it's quite high, this pressure breathing, it'll damn nigh blow you up. The moment pressure breathing comes in, you've got to resist it. You've got to push against it. And then just let a little air come in, only for a second, because it's coming in under high pressure, and then you blow out again. So it's the reverse of normal breathing. Of course, breathing is a subconscious action. You don't think about it. But if you do think about it, you actually breathe consciously. You breathe in, you go, and you breathe in. Now, with pressure breathing, it's the reverse. You've got to push against the incoming air. And you've got to do it like every 4 or 5 seconds. It takes an awful lot of discipline to do it properly. But, of course, it is absolutely essential that you do it properly, because if you're flying the aeroplane and you conk, you're in deep trouble, because the co-pilot might have conked already. You need this very high level of discipline. And then you would bring the aeroplane down, say from 66, down to about 40 or 35, and that's a job in a Concorde. It takes hours to get down from there. I mean, I'm only speaking comparatively. And then you could put your visor up and breathe ordinary oxygen. But you see, the safety training and the safety equipment was the pain in flying the prototype aeroplanes. And the steel visor on 001, 002, well, 001 and 002. Now,
Brian was telling me also that I think it was 001 had the tiny windows again.
Yes, it did.
Side
yes.
windows,
Yes.
which were a problem.
But having said that, the only other things on Concorde was the vibration on the flight deck when you taxied over rough ground. Because if you think of it, the nose wheel itself is miles behind you, and the main wheels are miles behind that. And when you stuck out on this long stick and you taxi over rough ground, the up and down shaking is very marked, and you shake like mad all over the airplane. Anyway, it handled well on the ground. It goes like a rocket on takeoff, and it flies like a bird in flight. And as the program developed, it was obvious it was going well. Concorde did the bulk of the work. I reserved for myself only what was supposed to be the hard bits, the high incidence work, and all the single failures, like single engine failure takeoffs and landings, and double engine failures, and double ADC failures. They are very critical on the Concorde.
Double?
ADC, air data computers.
Oh, yeah.
Everything is measured on Concorde, and it's brought into the aeroplane, and it is processed, and it's given to the pilot in true Mach number, airspeed, and all the safety systems which need to know Mach number and airspeed and altitude. They're all sophisticated to the nth degree, which means that if you fail an ADC system, if you fail one, it's no sweat. The other one looks after the ship. But if you fail both, you are back on what they call raw data, and you've got to fly the aeroplane with some care, because you are no longer looking at true values. You are looking at gross ignorant values, but they are still accurate enough to fly. Now, to fly a Concorde ordinarily is absolutely no problem whatsoever. It flies like a bird. It flies very like a 7.4. They are both light and precise, and have exactly the right degree of stability. The engine out failures were no different from any other aeroplane. The engine out landings were a gift. The two engine out landings were a gift. There's bags of thrust available on two to make a proper landing. There's no such thing as a flapless landing, of course, because it hasn't got any flaps. The engine failure at Mach II is a complete non-event, but better than that. The double engine failure on one side at Mach II, the machine will tolerate without any trouble. Now, if you tried this, well, you couldn't try it and survive it. If you did it on, there was an American supersonic bomber, forgotten the name of it.
Hustler?
The Hustler, yes. It had a delta
Yeah.
with no sophistication, just a straight angular delta and 4 engines. If you lost an engine at Mach II, that aeroplane instantly dissolved into another cloud of aluminium dust. It yawed like the clappers and broke up.
Because the outer engines are virtually on the wingtips.
They were a long way
Yeah.
out. Now, on Concorde, you can do a Mach II cruise, and you can get hold of 3 and 4 and shut them straight down. And the machine doesn't give a damn, which is a fantastic achievement. It will actually yaw to the right, of course, because you've lost those engines, but it rolls the wrong way a little bit, and it puts the left wing down, and you find yourself flying, and you think, oh, that's uncomfortable. But you don't have to do anything. You can sit there and say, well, isn't that marvellous? And then you pick the wing up, and then you correct the yaw with a bit of rudder, and lo and behold, you're dead straight, having suffered a coincidental loss of 2 engines. It's fantastic.
Now, how did the approach on Concorde compare to the ones you flew on a Vulcan?
Well, it was stable to start with, but the funny thing about Concorde is the visual picture which puts you off. If you put a new pilot into Concorde and didn't tell him anything and say, come and do a couple of circuits, he would get terribly, terribly low on final approach. I did. I mean, trouble let it happen. He sat there at Fairfoot laughing his head off. And because of the way you sit up, you see, like this, you think, hell's teeth, I'm miles too high, there's the runway, and you find yourself coming down. And if people watched you, like from the control tower, they would see the aeroplane come down very low out and then drag itself in. Whereas what you've got to do is to have the courage to keep it up here and then come down a bit like a lift, you see, because of this high attitude. Once you've been shown it once, it's okay. And of course, mostly you fly an ILS glide slope anyway, so that's no trouble.
And a radio altimeter for flaring, did you have?
Yes, it does. Now, you see, they had difficulty making soft landings as a kick-off, because when you land a conventional, particularly UK aeroplane, as you close the throttles, you flare the aeroplane. Now, on Concorde, all that did, when you flared, was to lower the tail, and the main gear hit the ground even harder than it would have hit the ground had they not done it. And they've had some terribly hard landings. There was a guy called Frankie, one of the French development pilots, who took Giscard d'Estaing to the Azores, and he made a landing at 10 feet per second on the gear. Well, at 11 feet per second, the gear would have broken. Mind you, he was a bit split arsehole, Frankie. He did awful things. He flew very show-off approaches, which he shouldn't have done. And, of course, he nearly copped it, but not quite. But in the end, it was Jock Cochran who discovered the way to land it, and it's the way you land a 7-4. You don't flare the airplane, you don't do anything. As you come down, you just leave the stick alone, and as you come through 50 feet, you get hold of the throttles, and you shuffle them shut. You don't whop them shut. You shuffle them, takes about 2 or 3 seconds. You just pull them back, and the machine sinks into its own little bit of ground effect, and the next thing you know, rumble, 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 and you're down. And it's a piece of cake. You can do it every time. And that's exactly how you land a 7-4. And of course they are both vastly different plan forms. Now, the other failures on the aeroplane, the only one of any consequence was longitudinal short period pitch damping. Because, you know, a slender delta is unstable over small angles. And if you didn't have any pitch damping, it'd do this all the time. And it's very sick making. It's got a duplicated pitch damping system about all axes. The aeroplane is supposed to survive with them both failed. Because if you remember, I told you earlier that a modern transport aeroplane must survive all probable double failures. The only exception to that is a double engine failure on a big twin, which is a separate case which we'll come to in a minute if you're interested. So one of the most demanding cases on Concorde is a double ADC failure. It gets rid of all your primary instruments. It gets rid of all short period pitch damping. And if it happens at Mark II, and you were silly enough to get hold of the aeroplane, like actually take hold of it, you'll make everybody sick within a minute. It's going like this all the time. The thing to do is the thing to do with all aeroplanes. Leave the bloody thing alone. Just leave it alone. Now, if the machine starts to climb, which you don't want it to do because you were supposed to be at 60, you just touch the trim button. You just give it one little poke and it'll come down. And if it's sinking instead of staying there, you trim the other way and it'll come up. That's all you do. But of course, with a double ADC failure, you can't stay up there. You've got to come down. And you don't have all this magic protection on the engine intakes. So back on the engineer's panel, there are 4, I think they're called ETA gauges. And when you work the throttles manually, you've got to take great care to do it slowly and keep this needle in the center of its range. If it starts wandering one end, you are closing the throttles too quickly.
What are the gauges measuring?
They are measuring some funny pressure in the intake. And if you get it wrong, you'll get an intake bang, you know, a terrible compressor bang. It sounds like, as Trump once said, the next war starting. It's a terrible bang. And of course, a very bad one could damage some of the intake. It could blow the panels off. But if you watch and of course at the same time you're flying the aeroplane. But it doesn't matter, because as I've said, leave the damned aeroplane alone, set it up to go downhill, get hold of the throttles, look at these ETA gauges, and close the throttles, and start to get the speed off and get the height off. And you can do it. I mean, I've done it several times. It's no problem. And then when you get below 1.6, you can shut the throttles fully. It's not critical any longer.
Otherwise, all the intake wraps are computer controlled.
Oh, absolutely.
You don't have to do anything.
No, no. Ordinarily, you don't have to do a thing. But I was very lucky. I flew all 6 prototype Concordes for different programs. And on the last one, which was out of Charles de Gaulle with Gilbert de Feur, who was their chief development pilot. He was a great guy, Gilbert. We put in every known failure on this flight. And the last one was to have a double ADC failure at Mark II. And we were out over the Bay of Biscay. And we did that. We just failed too. And then he said, right, now we got to take the aeroplane home. And I flew it manually all the way from Mark II at 60,000 back into Charles de Gaulle. With no stall protection, no stick shakers, no regular airspeed. I mean, we had airspeed, but it was standby airspeed on a little instrument. But you see, I'm a very conservative and old-fashioned chap. And while all this new magic stuff is great, you can keep it as far as I'm concerned. As long as I've got my mechanical standby instruments looking at me, which is always pitch and roll attitude, height, and airspeed, you can bring any aeroplane home on that. Any aeroplane without any trouble. And we brought this aeroplane back into Charles de Gaulle and parked it. And Gilbert said, God, he said, that was a marvellous demonstration. And I said, well, it was a marvellous demonstration of your aeroplane. If you know what you're about, it's an absolute gift. So at the end, we were tickled pink with Concorde. It's a super aeroplane, it really is.
Another thing that strikes me, you went into great detail about the suits you had to wear on the first prototype and so on. Whereas nowadays, I think the achievement of making such a huge quantum leap, doubling an airliner's cruising speed, and you fly it in shirt sleeve conditions. I mean, the passengers are squeaking back the champagne.
Yes.
The pilots are relaxed, whereas originally it was virtually like an Apollo takeoff.
It was, yes.
Yeah.
Now, the reason for that, of course, is that the pressure cabin is to a very high standard, which, of course, it has to be. And all the passenger windows are small. They're tiny. Have you ridden in Concorde?
No.
Well, when you get inside, because of the clever way they've done the decor, you think you've got big windows, because around them they've painted these big shapes, you know, and you think, oh, look at that. But when you actually look through them, they're probably that size. Now then, they've figured out that if you lose one of those windows at 60, it'll be a big upset. You start losing cabin pressure, but at a rate at which you can survive. I mean, all the lunch things on the nearest passenger's table will go pow straight out. But A passenger wouldn't get sucked out. In fact, if the local passenger got sucked to it, that would be great, you see. It would fly Yeah. But they can live on Concorde with one cabin window gone. They couldn't live with a door, but you see, the door is primary structure. Touch wood, the door won't fail.
Well, that's where all the money went in perfecting really a fighter.
Yes, I'm okay.
Type aircraft.
Yes.
Right, that's it on Concorde?
That's the end of Concorde, as far as I'm concerned.
If I can just pose a final general question, which occurred to me last time, and I thought, no, let's have it right at the end of the tape. Every country that operates airliners has an inspectorate system, presumably. You have a opposite number, say, in Germany and places like that. Now, are they as thorough, or are you a bit like a Lloyd's leading underwriter? If it's okay with you, it's okay with them. Because, you know, you were a bit of a pain in the arse to Boeing from time to time.
Yes.
Were they equal pains, or were you the sort of bloke who caused all the trouble and smoothed everything up for the people to follow you?
Well, you see, I have to be careful answering that question, because to anyone else listening to this, they might think, what a cocky bugger. But the truth is that the ARB and the CAA, particularly the old ARB, in its day, was the only airworthiness authority which did behave properly on the flight side. Now remember, I'm only responsible for the flying qualities of an airplane. Structures and engines and stuff, nothing to do with me. But we had a very elementary approach to everything. We had a good book of requirements. They enjoyed my confidence because we'd written half of them ourselves. And we flew aeroplanes to them. And if an aeroplane failed to comply, if it was a significant failure, we turned it down flat, and that was the end of it. It didn't matter what the constructor said. I've told you all things about Britannia and other aeroplanes. Even the poor old Ambassador had its problems. The chief designer comes along to your boss, wringing his hands and saying, oh, Christ, that guy Davies, he's done it again. It's going to cost a fortune, put the program back. It's rubbish. If they've got the wit to design an aeroplane, they've got the wit to put it right. I've never known any aeroplane fail to qualify in the end, given enough time and steam and money. But the only other significant authority for years, and for my money even now, is the FAA. And the FAA lacks courage, political clout. All the American constructors can dominate the FAA for political and economic gain, and they do. And the DC-10 cargo door was the very best expression of that ever. I have no time for the FAA flight certification of an aeroplane. If people say to me, but the FAA have certificated it, that is supposed to generate confidence in a listener. It does round the world. If you go to Africa, or even Australia and New Zealand, and say it's FAA certificated, they think, oh great, it's safe, it's proper. Is it hell? If somebody tells me the FAA certificate is something, I am instantly skeptical of it, because I know how they work. When Gordon Cole went over to do the Learjet, which was already certificated, he was so appalled by the failures to comply, admitted by the company, that he didn't even fly the program. He said, I'm wasting your kerosene if I fly that. Go and fix all those 8 things, and I'll come back in a year's time. Now that was the strength of Bill Lear, his own personal dominance of the local FAA office. He absolutely flattened them, and they bought the aeroplane. I told you earlier, Dick Sliff was virtually forced to buy the original 707 with that appalling directional stability. Now you see, we didn't let anything influence us other than the flying qualities of the aeroplane. After a bit, although I listened politely to what the constructors told me about the aeroplane, it was a waste of time. I was just waiting until I could get my hands on the aeroplane and fly it myself. And then what I believed was what I found out. Now the one exception to what I've just said, which is it was only ARB in the early days, and hopefully still CAA now, who know what the hell they're talking about, and are prepared to stick out and make sure aeroplanes are right, it is still accepted that the Dutch RLD, which is their certification authorities, are aces on structural matters. But BC structures is outside my field.
Yeah.
So that was that.
Fine.
But you see, having made that claim that the sun shone out of our arse, which in fact it damn well did. We worked hard for 30 years. This sort of confession of mine about these two accidents, which I still feel a bit sad about, the Comet 1 ground stall and the Trident droop lever being separate from the flap lever. Now, both those aeroplanes, well, let's do the Comet 1 first. The Comet 1 loss on takeoff was due to the fact that the pilot could pull it to a very high attitude before striking the tail, at which the wing would stall and the machine would never leave the ground. That was, in our view, irrational behavior. We never thought anybody would do it. We didn't check it. Years later, the Trident 1 was lost by the droop being selected up at very low speed before the Heathrow accident. And again, that was the result of a completely irrational act. I accept that the machine was capable of being mismanaged to that degree, but we never thought it would be. So, in a funny way, I feel a touch of guilt about that, but not too much. The main problem is that if you step outside the boundary of rational behavior, there is no horizon. There is no limit to irrational behavior, and you cannot plan against it.